In the area of science and philosophy, few ideas spark as much intrigue as the concept of consciousness, what it is, where it resides, and what happens to it after death. At the forefront of this exploration stands Roger Penrose, a celebrated mathematical physicist whose groundbreaking ideas challenge the conventional views of both physics and consciousness. This video looks into Penrose's revolutionary theory that suggests consciousness may operate through quantum mechanics, proposing that it could, in fact, persist beyond physical demise. Join us as we unravel the complexities of Penrose's theories and the profound questions they raise about the essence of human experience. Roger Penrose, a name synonymous with innovation in the scientific community, has carved his niche as one of the most profound thinkers of our time. His extensive work in mathematical physics, particularly in the areas of general relativity and cosmology, has not only expanded our understanding of the universe but also challenged how we perceive the very fabric of reality. Penrose's contributions are not confined to one field, they span across multiple disciplines, bringing a unique perspective to each. Born in 1931 in Colchester, England, Penrose started on his academic journey at University College London and later at Cambridge University, where he interacted with some of the brightest minds in science, including the legendary Stephen Hawking. Together, Penrose and Hawking developed the Penrose-Hawking singularity theorems, which provided mathematical evidence for the existence of black holes, once a mere speculation, now a cornerstone in astrophysics. Penrose's curiosity didn't stop at black holes and the cosmos. His passion for understanding the universe's mysteries led him to tackle one of the most perplexing phenomena, human consciousness. Penrose ventured into this domain, proposing radical ideas that linked the workings of the quantum world to the enigmatic processes of the human mind. To fully appreciate Roger Penrose's contributions to the theory of quantum consciousness, one must first grasp the fundamental principles of quantum mechanics. This field of physics is notably distinct from classical physics, which governs the everyday world of apples falling from trees and planets orbiting the sun. Quantum mechanics applies to the subatomic particles that compose the universe's fundamental building blocks. Here, the rules of classical physics no longer apply, and new, often bewildering behaviors emerge. At the heart of quantum mechanics are concepts like superposition and entanglement. Superposition allows particles to exist in multiple states at once until an observation collapses these states into one. Imagine a coin spinning in the air, it's not just heads or tails but both at the same time, only settling on one when it lands in your hand. Entanglement, on the other hand, is a mysterious phenomenon where particles become interconnected no matter the distance separating them. Actions performed on one entangled particle affect its partner instantaneously, a behavior Einstein famously derided as spooky action at a distance. These principles, though counterintuitive, are not just abstract notions but have been demonstrated through numerous experiments, underpinning technologies like quantum computing and leading to profound philosophical inquiries about the nature of reality. It's in this strange and fascinating quantum realm that Penrose seeks answers to questions about consciousness, proposing that if such peculiar interactions occur at the microscopic level, could they not also influence our conscious experience? Penrose's exploration of quantum mechanics is not about discarding the old to make way for the new but rather about expanding our understanding in ways that bridge the seemingly vast chasms between the seen and the unseen, the tangible and the abstract. This approach sets the stage for his foray into the even more complex world of consciousness, where he applies the principles of quantum theory to propose a model of consciousness that is as intriguing as it is controversial. As we transition from the foundational principles of quantum mechanics into the realm of quantum consciousness, we enter a space where science begins to intersect with the profound aspects of human experience, consciousness itself. Quantum consciousness is a theory that attempts to explain consciousness through the lens of quantum mechanics, a significant departure from classical explanations which primarily view consciousness as a byproduct of chemical and electrical interactions in the brain. Quantum consciousness proposes that the small-scale operations of quantum mechanics, like entanglement and superposition, might play an integral role in the functioning of the brain, and more specifically, in the phenomenon of consciousness. This theory suggests that our conscious awareness is the result of quantum processes within the neurons of our brains. It's an appealing model because it attempts to address one of the most puzzling questions in science: how and why does consciousness arise? Roger Penrose, alongside anesthesiologist Stuart Hameroff, proposed the Orchestrated Objective Reduction (Orch-OR) theory, which serves as a comprehensive attempt to integrate the principles of physics, biology, and consciousness studies. The theory is built around the idea that inside neurons, more specifically within cellular structures called microtubules, quantum processes influence cognitive functions. These microtubules are proposed to be the seat of quantum activities, including superpositions that could correlate to the brain's cognitive processes and ultimately, to consciousness itself. The Orch-OR theory posits that these quantum states are maintained in coherence for sufficient time and then undergo a specific type of collapse, known as objective reduction. Interestingly, Penrose suggests that this collapse is not random or purely physical but is orchestrated by the biological processes of the brain. It's through this orchestrated collapse that consciousness arises. The theory uniquely ties the occurrence of these quantum moments to the emergence of experiential moments, our awareness. A pivotal aspect of the Orch-OR theory is its suggestion that consciousness results from something fundamentally non-computational, which cannot be simulated by artificial intelligence or digital computers. This sets it apart from other theories that equate the brain's workings to computational processes. Penrose suggests that the non-computational elements involved in quantum processes might provide the missing link in understanding the enigma of consciousness. This theory does not just redefine our understanding of what consciousness might be, it also extends the implications to suggest continuity of consciousness beyond physical death. If consciousness is indeed a sequence of quantum processes at the micro level, it opens up the possibility that these quantum states could transition to different states beyond the physical structure of the brain, suggesting a form of consciousness that could exist independently of our physical entities. The exploration of consciousness stretches beyond the tangible, tapping into questions that philosophy, psychology, and now quantum mechanics seek to answer. Traditionally, consciousness has been seen as a result of complex neurological activities within the brain's vast network. But this view leaves unanswered the hard problem of consciousness: why and how these processes produce the subjective experience or qualia, such as the redness of red or the pain of a headache. Penrose's Orch-OR theory provides an intriguing alternative by suggesting that the answers may lie in the quantum state reductions occurring within the brain's microtubules. This quantum perspective does not simply reduce consciousness to the firing of neurons or the synaptic exchanges of chemicals. Instead, it proposes a layer of quantum operations that could bridge the gap between physical processes and subjective experiences. The suggestion that consciousness could derive from quantum-level interactions within the brain's infrastructure provides a fresh perspective on old questions and offers a new platform from which to understand the phenomena of conscious awareness. The implications of Roger Penrose's Orch-OR theory are profound and far-reaching, particularly when considering the continuity of consciousness beyond physical death. If consciousness arises from quantum processes at the microtubule level, it suggests a mechanism where consciousness could persist, at least in theory, independent of the biological structures that currently house it. This presents a paradigm-shifting perspective on life and death, suggesting that consciousness could be more akin to a state of being that transcends our physical existence. This theory resonates with, and even provides a form of scientific backing to, various spiritual and philosophical beliefs about the soul surviving physical death. If consciousness can exist outside of the standard neural networks, it could potentially exist outside of the body. This could change the way we approach everything from artificial intelligence to end-of-life care, offering new insights into what it means to live and what might come after. This perspective challenges the materialist view of the mind, opening dialogues between different disciplines like theology, philosophy, neuroscience, and quantum physics. It invites us to consider that the essence of who we are, our consciousness, might be a fundamental part of the universe, just like matter and energy. With any groundbreaking theory that steps away from conventional thinking, Roger Penrose's Orch-OR theory has not been without its critics and controversies. The scientific community, particularly those working within the fields of neuroscience and quantum physics, has raised significant skepticism regarding the plausibility of quantum processes playing an active role in consciousness. One major point of contention is the lack of direct experimental evidence to support the idea that quantum states within brain microtubules influence conscious thought and perception. Critics argue that the warm, wet, and noisy environment of the brain is unsuitable for maintaining quantum coherence, which is typically observable only in controlled, isolated conditions at very low temperatures. Many neuroscientists maintain that existing neurological theories already adequately explain the mechanisms of consciousness through neural networks and brain biochemistry, without the need to invoke quantum mechanics. They suggest that Penrose's hypothesis, while fascinating, may be an unnecessary complication in the already complex understanding of brain functions. Despite these criticisms, the Orch-OR theory continues to provoke interest and debate, highlighting the often incomplete nature of current models of consciousness. This controversy underscores the broader challenge in science, to adequately explain not just the mechanisms of thought, but the reasons for subjective experience and consciousness itself. In response to criticisms, supporters of the Orch-OR theory point to a growing body of research that suggests quantum effects could indeed play a role in biological processes. Recent studies in quantum biology have observed quantum coherence in photosynthesis and bird navigation, hinting that nature may harness quantum mechanics more widely than previously thought. Although these phenomena are not directly related to consciousness, they suggest that quantum processes could feasibly operate within the biological realms of living organisms, potentially supporting the conditions proposed by Penrose and Hameroff. Experimental advancements are beginning to offer tools that could test the predictions of the Orch-OR theory more directly. Developments in quantum technology and neuroimaging techniques may soon provide insights into whether quantum coherence can exist in the brain's microtubules and affect brain function. While conclusive evidence is yet to be seen, these developments keep the door open for the potential validation or refutation of Penrose's intriguing hypothesis. As research continues, the debate over the Orch-OR theory serves as a fertile ground for interdisciplinary dialogue between quantum physicists, neuroscientists, and philosophers, all exploring the profound question: what is consciousness? The ongoing investigations and discussions not only reflect the evolving nature of science but also, crucially, push the boundaries of our understanding about the human mind and the possible continuities of consciousness beyond our current physical perceptions. The implications of Roger Penrose's Orch-OR theory extend beyond the scientific realm, stirring profound philosophical and ethical debates. If consciousness can indeed persist beyond the physical death of the brain, as suggested by the quantum processes described in the theory, it raises fundamental questions about the nature of existence and self-identity. This perspective might suggest that consciousness is not merely a byproduct of neurological activity but a fundamental aspect of the universe, akin to matter or energy. Such a view resonates with various philosophical and spiritual traditions across the world, which posit that consciousness or the soul is eternal and transcends our physical existence. This alignment between a scientific hypothesis and ancient philosophical beliefs invites a re-evaluation of how we understand life and its purpose. It challenges the materialistic framework that has dominated scientific thinking about the mind, urging a broader, perhaps more inclusive view that acknowledges the possible non-material aspects of human existence. The potential for consciousness to exist independently of the body raises significant ethical questions, particularly in the context of medical and end-of-life care. It compels us to reconsider our approaches to death, dying, and the decisions we make about life support and organ donation. If consciousness does not end with brain death, what does that mean for our criteria for death and the respect and care owed to those who are dying? In exploring Roger Penrose's Orch-OR theory, we've looked into an area where science meets philosophy, where the questions about consciousness challenge not only how we understand the brain but also how we perceive reality and existence. While the theory remains controversial and faces significant scientific scrutiny, it underscores the deep mysteries that still surround the phenomenon of consciousness. As research progresses and as quantum technologies advance, we may find clearer answers to these questions. Or, we may discover that consciousness is even more complex and enigmatic than we currently imagine. Regardless of the outcome, the pursuit of understanding consciousness through quantum mechanics highlights the human drive to explore and understand the very essence of our being. This journey through quantum consciousness with Roger Penrose reminds us that science is not just about answering questions but about asking deeper, more meaningful ones. We encourage you to look into the theories of Roger Penrose and other pioneers in the field of quantum consciousness. Engage with this content, read extensively, and participate in discussions that challenge and expand your perspectives. What do you think about the idea that consciousness might be an intrinsic part of the universe, just like particles and forces described by physics? Share your thoughts and join the conversation as we continue to explore one of the greatest mysteries of science and philosophy.